Hi everyone. In this video, we will learn how to calculate for the mean, variance, and standard deviation of a discrete random variable. In our previous discussions, we've learned that a random variable has two types, a discrete and a continuous random variable. A discrete random variable is a random variable whose possible values are determined by counting. In this video, we will learn how to calculate for its mean, variance, and standard deviation. It is also important that we understand the concept of a mean, a standard deviation, and a variance. Mean refers to the theoretically expected value, and it is represented by the Greek letter mu. The standard deviation is represented by the Greek letter sigma, the Greek letter lowercase letter sigma, and it refers to the distance of the values in the population set with respect to the expected value. It answers the questions: how far are the values in the data set from the expected value? On the other hand, a variance, which is denoted by sigma squared, is simply the square of the standard deviation. As we go on, you will more understand these concepts. We need this formula for us to be able to calculate for the mean, which is denoted by mu equals the summation of the products of the possible values and the probabilities. For the variance, we have sigma squared is equal to the summation of the differences of the square of the possible value and its corresponding probability and the sum or the square of the mean. While to solve for the standard deviation, we simply have to determine the square root of the variance. Let us have the problem on how to calculate the expected value, or we refer it as the mean. To solve for the expected value of a discrete random variable, first is we construct a probability distribution table. In some cases, it is already provided, but if it is not, then you have to construct it. Second is to get the product of the possible value and its corresponding probability. And last is we get the sum of those products, and we now have the mean of our discrete random variable. Let us have example 1. Suppose you tossed 3 coins simultaneously and you want to determine the expected appearance of head and the standard deviation. The probability distribution table in this example is provided, and it looks like this. We have here in the first column the possible values of our random variable, which is the number of heads: 0, 1, 2, and 3. And in the second column, we have the probability of that possible value. We have 1/8, 3/8, 3/8, and 1/8. To determine for the expected value or the mean of this discrete random variable, again, the first step is to determine or to construct its probability distribution table. In this case, it is already provided. Thus, we will proceed to the next step, which is we determine the products of the possible outcome and its corresponding probability. In other words, we have to insert another column to the right, and we name it as the product of the possible value and its corresponding probability. In this case, we have 0 times its probability, which is 1/8. We have 0. Any number multiplied by 0 is 0. And 1 times 3/8 is 3/8. Any number multiplied by 1 is the number. And 2 times 3/8, 2 times 3 is 6, divided over 8. And this one, in simplest form, is 3/4. And lastly, we have 3 times 1/8 is 3/8. We now finished step number 2. We have determined all the products, and we proceed to step number 3, which is we have to get the sum of all these products for us to be able to have the value of the mean of our discrete random variable. We express it here as the summation of the products of the possible value and its corresponding probability. We have 0 plus 3/8 plus 6/8 is 9/8 plus 3/8. We have 12/8 or 12/8 in which is equal to, in simplest form, is 3. It's 4. Yeah, it's 3/2 or 3/2, which is equivalent to 1.5 in decimals. Thus, we have the mean of our discrete random variable is 1.5. There you have it, the expected value of our random variable, which is the number of heads.